Hi, am I audible? Yeah,
Yes, yes,
yeah,
ma'am.
sure.
Audible.
Okay, thank you. Um, so just wait for a couple of minutes to see if anyone else is joining, and then I'll start the class. Yeah, a very warm good evening, everyone. So, yeah, for the last class, I was discussing about the Warburg. So, basically, just a slight, actually, the derivation, because someone had asked me to solve the derivation. So, yeah, today's class, I'm planning to complete the derivation as well as discuss the questions of assignment 8, I think, yeah, that related to this Warburg. That's why I thought I'll first finish the uh, derivation and then move on to that. So, yeah, so I'll just give a brief uh, summary of what was taught in the last class. So, yeah, in the Warburg, we started seeing like till the previous, before Warburg, we were seeing how to solve the mechanism or how to derive the mechanism without by taking into consideration that mass transfer is not rate limiting. In fact, you have enough materials available at the electrode electrolyte interface. But then we saw that. If mass transfer comes into account, though you'll have something like the concentration of A in the bulk will be something like Ca bulk, but at the electrolyte interface, you will not be getting that much amount of material. In fact, there will be some deterioration. So, because of that, along the boundary layer, you will have some change in the concentration, and towards the surface, you will get something in the form of CAS, that is the surface concentration. So, when we were calculating the rate in the mechanism, we were actually taking concentration of A as such, that is which I mean of any material as such, if we are not taking into consideration the mass transfer limitation. But once this thing, that is mass transfer, comes into account, that is not the case. You will have a concentration of the electrode surface that is different from that in the bulk. And when you take that into consideration, you are not knowing what exactly is the value of that surface concentration. It will be actually something different from the bulk, and that is an intermediate value. So you cannot. So in the mechanism, you will have to have another set of equation to find out what is that value. Okay. So in that, yeah, we saw for the semi-infinite boundary conditions. So similarly, we wrote the expression for the current. Then we found out the relationship at equilibrium. Then we also saw how is the kinetics limited and kinetic plus mass transfer limited different. Yeah, then based on that, we wrote the equation for the current. Yes, we had written, there the concentration terms at the electrode surface will be different from that in the bulk, and then we have to find that out. So for that, we found that at equilibrium, both will be equal, the forward and the backward reaction, and from that you get the expression for K1 C bulk and Cb bulk. In fact, if you know one of the bulk concentration, you need not have to know. I mean, you might not be given in any of the question as directly Cb bulk. In fact, you will have to find it on your own because there's a relation. Then we applied the Fick's law, and based on that we found out the concentration. Then yeah, so from that, based on the conditions at how it is at x is equal to 0, that is at the electrode-electrode interface, and at the bulk, that is at del, boundary layer thickness of del, how then from that you found out the CAS and CBS, right? Again, you also use the Fick's law condition, and from that you derive both. Then after that, so after you find out CAS and CBS, the next thing is to find out the impedance. So how did you do? You wrote IF, okay, and then from that, again there are, instead of one unknown, that is instead of current, you have CA and CB, which is also unknown values. So how to find out? Then you wrote del IF as a function of the potential and the concentration terms, and then you differentiated it and found out each term. So basically express IF as a function of CA, CB and E, and all three are independently dependent on IF, and you differentiated the equation to find out the concentration. And then after that, similar to like how we take the perturbation for the potential, you consider the same kind of perturbation for CA and CB, and finally by applying the boundary conditions, you find out the constants, and finally you get those terms. And finally, I had asked you to write, try solving it, and you're getting del IF and ZF. Did anyone try? Are you able to get this? Are you able to get this? So this is where we had stopped. So yeah, I just wanted to discuss few more expressions so that that will help you to solve the what to say, the assignment questions. So that's how I'll be moving on. Okay. So why I'm deriving it is just to make you familiar with all the terms so that that will help you in assignment solving. So today's plan is to complete this derivation, then move on with the assignment. Then again I'll pause. Then I'll do this the finite boundary condition expression also derivation. Then we'll also do the last two questions is related to that, and finally we'll sum that up. So that's what my plan is. Okay, because there was so much doubt on assignment. This assignment. So you get something of the form. So did anyone try this out, the derivation? Like someone had asked me like how to do the derivation. That's how I started doing it. Did anyone try? So I was quite curious to know, did you even try doing it? Because so this is the equation that we derived for the last class. So yeah, this was the equation we had. So this is the expression we derived, and then we say that this part, that is, this is a combination of the resistance to charge transfer plus the bounded Warburg. So there is both due to A and B. Okay, so that's how again the bounded Warburg terms, like if I say it is totally from A and totally from B, still we cannot say that exactly because still there are some combination of terms like CA and CB coming. So it is not like this comes only from A or this comes totally from B, but we are trying to say like that. So RT is something like 1 by F into this entire term. So this was one of the assignment question, if you remember, to find the resistance to charge transfer. So this is resistance to charge transfer, and the next one is ZA. So that one will be, then resistance to polarization was also asked, that I'll show you. So when that question comes, I'll show you how to do that. J omega dA by F B1 K1 DC CA at x equal to 0 minus B minus 1 K minus 1 DC CB at x equal to 0. So ZB will be same thing except that this term will change. So it will be K minus 1 DC by root of J omega dB. Okay, so these are the terms. Now the another question that was when EDC equal to 0. So for the same case, what will happen if EDC equal to 0? That's something else you have to look into. So that's kind of a special case. So that means there is no potential applied. So how will the equation change? Anyone? Anyone knows? Or anyone can tell me what happens? So what all terms will change from this equation? Can anyone tell me? So if the potential applied is 0, like which all terms will it affect? I'm audible, right?
Yes, you are
Ah,
audible.
yeah, yeah, sure, thanks. So yeah, that was another question in the assignment. Like when EDC equal to 0, so what all terms in the impedance will be affected? I mean, how can you, what to say, simplify this case? Yeah. So can anyone so what does EDC equal to 0 means? That means there's no potential. I mean applied. That's at OCP. So can you tell me which all terms in that ZF equation is related to potential? So what is the formula for K1 DC? What is the formula for K minus 1 DC? Anyone? So you know it is proportional to k is always proportional to exponential raised to potential, right? Correct, right? So k1 dc will be nothing but k1 naught e to the power edc, b1 edc, right? So this I think is question related to question 6 or 7, right, of the assignment, or 11 I think. Yeah, 11th question of the assignment. We'll discuss the assignment just before that, giving a brief outline on what exactly is asked in the assignment. Okay. So same way k minus 1 dc will be nothing but will be k minus 1 0 e to the power b minus 1 edc, right? So I'm telling edc becomes 0. So what is k1 dc? Now at least someone tell me what is k1 dc? K1 dc will be nothing but k1 0, because k1 0 e to the power b1 edc, edc is 0. So this entire term becomes 1. So this one will be k1 0, right? So for that question 11, I think you will have to use this substitution. K minus 1 dc. This one will be k minus 1 0. Now what will be the next change in the equation? So db, da and all will be the same. But you will see another term. C at x equal to 0, cb at x equal to 0. So what are they? See, what does that mean? It's the surface concentration. When will there be a concentration gradient in the solution? When there is a potential, when the reaction is happening, you have some bulk concentration, okay, and when reaction progresses, that means you are applying some potential. That's when you are forcing a reaction to happen. So surface concentration will be different from that of the bulk concentration. So that case where there is no potential applied, will there be any reaction happening? Will there be any concentration gradient across the solution? No, it won't be there. So in that case, Ca at x equal to 0, you will have at EDC equal to 0, I'm talking about Ca bulk. Similarly, Cb at x equal to 0 becomes equal to Cb bulk. Okay. So these are the conditions you have to use when EDC equal to 0. Now, when you substitute in this equation, that is this part. I'm talking just about the first I'll just simplify the denominator. That is this part. That is what? F into B1 K1 dc C at x equal to 0 B minus 1 B minus 1 K1 dc C beta x equal to 0. So what all I told, we are just substituting and seeing how this equation will reduce for the case of E1 EDC equal to 0. So I know B1, okay, equal to alpha F by RT. So this one electron transfer process we have already written, A giving B plus A minus alpha F by RT. B minus 1 equal to minus minus 1 minus alpha f by RT. Okay, so and then we said this K10, this CA bulk. So same way the other side will be K minus 1 0 and this will be CB bulk. So just substituting that, okay, so you'll get something of this form. Into alpha F by RT, okay, K10, CA bulk minus 1 minus alpha F by RT K minus 1 0 CB bulk. Okay, now again we already know what is happening at equilibrium. The forward reaction will be equal to backward reaction. So that one is nothing but K1 DC CA at x equal to 0. I will write down at x equal to 0 will be equal to K minus 1 0 at x equal to 0. Now if I solve, so as I told, it's at EDC equal to 0. So this C1 K10, this CA bulk equal to CB bulk. So you see this term K10 CA bulk equal to, yes, tell me.
This is because forward reaction is equal to backward reaction. That is why we are writing this.
Yeah, at equilibrium.
At equilibrium.
Yes. Forward reaction will be equal to backward reaction. Same thing. But again, here the condition is, so that's forward reaction is this one. K1 DC at C, into CA at x equal to 0 equal to K minus 1 0 CB at x equal to 0. So we are considering the case where EDC equal to 0. Right? So K1 DC becomes equal to K10, right. CA at x equal to 0 is CA bulk. Same way K minus 1 0 and CB at x equal to 0 equal to CB bulk. So there's something in common. So I can take that out. So I'll write that in terms of F into K10 so minus and minus. So if I open this, so alpha F by RT and minus alpha by RT gets cut and finally F by RT will be left. Again if I combine with this, it will be K10 CA bulk, okay, F square by RT. Is this clear? So that's just the denominator part. Now what is RT? 1 by this denominator. So the denominator we have, so 1 by this part. So that we have already solved. So it becomes nothing but RT is 1 by reciprocal, reciprocal of this full thing, right? So reciprocal of this thing, because it is 1 by F into B1 K1 DC C at x equal to 0 minus B minus 1 K minus 1 DC CB at x equal to 0. So if I take that, I'm taking the reciprocal, I'll get something like RT by F square K10 CA bulk. So this is the RT value. Now what is ZW? ZW will be, so this ZW, right? ZWB, that is the bounded Warburg impedance, will be this part. So what will come here? K10 by root of j omega dA plus K minus 10 by root of j omega dA by this entire term. So TF square stable. So I'll get something like, I'm just the denominator part I'm writing first, which is K10 stable F square by RT into K1 DC j omega dA. So K1 DC is nothing but K10, so K root of j omega dA plus K minus 10 root of j omega dB. So if I'm taking the reciprocal, and solving it, I'll get something of the forms sigma root 2 by j omega, where sigma equal to RT by F square 1 by root 2 into 1 by CAB dA plus, so if you solve this, you'll get something of this form. So this is a simplified version for the at EDC equal to 0. What? So I've not done the derivation because it's been so. I mean, we have been discussing about that for a long period of time. You just have to rearrange this entire thing. You'll get this form. Okay. So yes. So that is about the semi-infinite case. So actually, if you want, you can again simplify, but I'm just stopping that part over there, and we'll move on with the assignments. Okay. So this is about assignment 8. Just give me some time so that I actually didn't what to say. I'll just load the questions. So I'm talking about assignment number 8. Okay. So if you remember, there are so many few mistakes in assignment 2. So yeah. So we'll just start discussing, and then meanwhile, actually I forgot to add the questions to my PPT. So the first question is, in case of rotating disk electrode, as per the Levitz equation, diffusion layer thickness varies as dash of the rotational speed. Is it square root, square, inverse of square root, or inverse of square? What is it?
Inverse of square root.
Yes, it's inverse of square root. So your del equation is something of the form. So anyway, I'll write down this equation because you will need it for the next question. 1.61 into d0 raised to 1 by 3 raised to minus 1 by 2 gamma raised to 1 by 6. So you can see this the term. I mean, this you can even represent by omega. So I've just represented it with the psi symbol. So this is a rotational speed, and so it is inversely proportional to the square root. So option C is the answer. Okay, I hope that is clear. Now the same equation you need to use. Okay, and you have to calculate the diffusivity. So diffusivity is nothing but 1.61 d0 raised to 1 by 3 omega raised to minus 1 by 2 gamma raised to 1 by 6. So diffusivity value is given, right? So given the diffusivity of the species as 10 to the power minus 5 centimeters square per second, that is this one. Kinematic viscosity as 10 to the power minus 2 centimeters square per second, and rotational speed as 225 rpm is supposed to calculate the del value. Okay, so what is the thing? So this in centimeter square per second, this is also centimeter square per second. Now you will have to convert rpm to rps and solve it. Could you please try it, everyone, and then we'll discuss. I'll give you a few minutes. Please try, everyone, and then we'll discuss the answer. I hope everyone has written down the values. Diffusivity 10 to the power minus 5, kinematic viscosity 10 to the power minus 2, and 225 rpm to rps. Okay, because I'm just stopping my sharing. I'll add the next questions also. Please try then by then. Okay. If anyone gets the answer, you can feel free to tell the answer.
Yes, ma'am. We can easily find.
Hmm.
Um,
So if you can tell the
uh,
answer. Equation is there, everything is there. You just have to substitute. So that's what I'm asking.
Here, 1 rpm is equal to mm,
Yeah.
0.1047 radian per second that you have to put, or
So
you have to convert it
RPM
in
to,
radian per
yeah,
second?
yeah, you have to convert into radian per second. How do you do? You have to multiply the value by 2 pi by 60. 2 pi by 60. So I'm not sure with the value. I have to check how much it comes. But it's RPM into 2 pi by 60 gives you RPS.
Yes, correct.
Okay. So how much you're getting? I'm actually adding the questions. I forgot to do that. I'll then discuss. So if anyone gets answer, you can tell me so I can stop and we'll discuss.
33.2 like something.
Yeah, correct. That's correct. So, okay, then I'll start. Yeah, it's around. I think you have to get that range also. Hmm. So I think my slides are visible. Okay, my slides are visible, right? So yeah, so D is directly given. Okay, kinematic viscosity is also given. Omega is given in RPM. So how do you convert it? Okay, there's a third question. Sorry, sorry. So RPM in omega you can convert by, you can multiply 225 into 2 pi by 60. So this will be in RPS, radians per second. So that's how you convert to radians per second. Okay, and you will be getting around 23.57. Now, how do you find out del? 1.61. D0 is 10 to the power minus 5 centimeter per square per second. You don't have to convert it. So that is to the power 1 by 3 into 10 to the power minus 2. That is raised to 1 by 6. And omega in radians per second is 23.57 raised to minus 1 by 2. So if you solve this and see, as someone told, you'll be getting around. So again, be careful with the units. They've asked you in. So what you actually get will be in centimeter. Someone had asked me, like when you're solving this equation, which unit you will have to get the del value. So it is in centimeter. I had clarified at that time. Okay, you will get around 10 to the power minus 3, I guess, right? So I had solved it before. So when you convert it into micron, you have to multiply. So you will get 33.16. So centimeter to millimeter into 10, millimeter to micron into 10 to the power 3. So totally into 10 to the power 4 you have to multiply. You get some answer like this. 33.16 micrometer. That is the answer. Now the next question. Same way, the only difference is in the omega value. At a higher, more RPM, what will you get? Please do it. So here there's no change. Like diffusivity is 10 to the power minus 5 centimeters square per second. Kinematic viscosity is 10 to the power minus 2 centimeters square per second. The rotational speed is 1600 rpm. So you'll get something like 1600 into 2 pi by 60. So how do you do the calculation? Like using calculator or Excel sheet or MATLAB? I suggest using Excel or MATLAB because I think ninth and I use MATLAB actually. So or Excel also you can use because the last two questions if you see you have to find out the real and imaginary part and you see it is something like k1 by root j omega dA. J is coming below and that too in a square root. So if you are going to solve by hand it will take so long. So it's always nice you try to solve this in Excel. So because Excel, if you already make that Excel also, you just put all the numbers already and you make a file and keep. In case you want to change the number, you just have to change. I mean, the entire code is there. If you're using calculator, then you'll again have to type and recheck, right? So rechecking will become easy if it's Excel or MATLAB. MATLAB is much more simpler. So it depends on your, if you know MATLAB, that's good enough. Otherwise, that's well and good. If you know Excel also, it's good enough.
But okay,
Okay.
ma'am. But how we will solve in exam these questions? These kind of questions? We don't
Exam,
have MATLAB.
yeah, so I expect such that last type of questions might not be there, I hope. And I'm sure like sir would have put the paper, you'll have 3 hours, I guess, right? 3 or 2.
3 hour.
Yeah, so the questions must be of that form. Like, not like, I mean, still, if you want, you can confirm in the discussion forum with sir. Like, if the questions of this kind will be there or not. But yeah, I'm talking about the assignment. Assignments might be more lengthy, right? Because you are given, it's a homework. You have more time. It's a takeaway work. Exam, I'm expecting, so we'll be preparing the questions according to that. So apart from that assignment part, I think this easier. So yeah. So for this, I didn't find directly the omega value. I substituted everything. So it is like del 1.61 10 to the power minus 5 by 3 1600 how much you're getting?
Around 12.4, I think.
Yeah, correct. So
Madam, I have one question. Micro,
yes,
what is the micro? It is not unit, right?
it's micrometer.
Yes.
Again, one more thing that I want to tell you is when you're solving, right? Sorry, make sure that you put some ample number of decimal points. In the sense, for some questions, if you're doing by hand, especially for your exam, also one question will come. So I think in question 6 and all. So that's a big equation to find out the CAS value actually. So don't chop off the decimal after first place. In the sense, do not. So if you, I have written here 1.243. Okay, I have done this by hand. 1.243 10 to the power minus 3. Do not chop off after the first decimal, because when you're chopping after first decimal, it will be something like 1.2 into 10 to the power minus 3. And when you're writing it in micro, you are getting 12 micrometer, right? If I'm writing something, so answer is going wrong. So if it is something which has a numerator and denominator, you solve it separately, and you're again chopping off the numbers. Okay, there can be some 10 to the power, some multiplication factor like into 10 to the power 2, 3 and all. So if you don't have those many decimal numbers, when you're multiplying it with 10 to the power something, that entire value changes. 12, see, though it is in micrometer, 12.4 and 12 is some difference, right? So if decimal range is given, there are high chances that if you chop off the decimal after one place and all, your answer will go wrong. So make sure that when you're doing some calculation, at least keep 3 decimal places. Okay, and then do the simplification. I mean, in any intermediate step, if you're trying to simplify or something, keep at least 3 decimal places. Because at least I'm telling, not that 6, 7, but still at least 3. Because if here you see, you have 1.2 into 10 to the power minus 3 centimeter. When you're multiplying with 10 to the power 4, see, our 4 places are going. So if you don't have those many decimal numbers, you are actually rounding it off to a wrong value. So keep this always in mind. Okay. So now the next question is, for a simple electron transfer reaction, coupling, mass transfer and kinetics at the electrode surface is described, right? So what we are doing, that's why so that was like we are using this in the derivation. So for a simple electron transfer, coupling of mass transfer and kinetics at the electrode surface is described by. So if you remember, at the electrode surface, we are relating the flux, okay, the flux of the species, that is of here it was A giving B, so the inlet flux of A to the output flux of B is related to IF by NF. So there the species flux, I have related it directly to the current. So that is a question. So they are asking indirectly about the boundary condition. That is, at the electrode-electrolyte interface, I am telling that the flux of species A, that is dA into dou Ca by dou x, equal to minus dou B into dou C by dou x, dou T, sorry, dou CB by dou x, it's x actually. At x equal to 0, T, and that is equated to IF by NF. Okay, so that is the condition we are using to get the condition at the electrode-electrolyte interface. So that is a question. I hope that's clear. So, no, sorry. So this is the option. Is that clear? So the next question. Consider the following reaction: A giving B plus electron. It's a reversible reaction. Concentration of A and B in the bulk solution are equal. When a negative bias is applied under steady state conditions on the surface, which one is the correct? Which one is the answer?
CA is greater than CB. First.
Huh? Sorry, I didn't hear. Option?
First one. CA
First one.
is greater than CB.
Okay, could you please explain why did you tell that? So what is happening? So Ca bulk equal to Cb bulk, but that cannot assure that Ca equal to Cb. So that's the wrong option. Option C is wrong. It could be any of the above depending upon the kinetic parameter. See, it has nothing to do about the kinetic parameter. What does it mean? Negative DC bias and positive DC bias. So basically, so forward reaction is an anodic reaction. So that is a positive potential. Forward reaction is favored and I'm applying a positive potential. Why? Because the forward reaction is a oxidation reaction. So if I apply positive potential, forward reaction will be favored. And if I am applying a negative potential, this backward reaction will be favored. Okay, so that's how the conditions are. Now, yeah, so forward reaction for positive potential and for a backward reaction, you have to apply negative potential. So, you know, as what to say, as the reaction progresses, so as now we understand it's a negative bias. So negative bias means obviously it is a backward reaction that is happening. Backward reaction in the sense B giving A. So as this reaction, when I am applying a negative potential, this reaction keeps on happening, and because of which what happens? Concentration of B will keep on decreasing. B is totally getting converted into A. So concentration of B will keep on decreasing and Ca will keep on forming. So your option is option A. Is that clear? Now, the next question. In the above case, okay. So above case, they meaning A giving B plus E minus. Relevant parameters are given as dA value is given, dB value is given, Ca bulk is given, Cb bulk is given. So dA equal to d and dB are 10 to the minus 5 centimeter square per second. Ca bulk and Cb bulk equal to 100 millimolar. K1 0 and K minus 1 0 equal to 10 to the power minus 2 meter per second. Okay, B1 equal to 19 volt inverse and B minus 1 is negative 19 volt inverse. Boundary layer thickness is 10 micron and EDC equal to 0.1 volt versus OCP and temperature is 25 degrees Celsius. Then what is CAS in millimolar unit? So how do you proceed? Anyone has any idea? So what is the CAS equation? That is concentration at the surface.
dA by delta.
Yeah, that equation.
In bracket Ca bulk
Yeah, Ca bulk
plus K minus 1 dC into Cb bulk.
Yeah.
Plus K minus 1 dC into Ca bulk.
dA by dB K minus 1 dC. So now, so if you know the equation, then it's easy. Are you able to get this correct for the assignment?
But here dA equal to dB, so that would be 1 dA by dB.
Yeah.
K1 dc plus p minus 1 dc.
Yeah. So this is the equation. So now the thing is you need it in millimolar. So first step is to make sure that all are in the same unit. That's D and dB are already in centimeter square per second. Ca bulk and all are given in millimolar. So you have to convert into mole per centimeter cube because you have D and dB. So it's up to you. You can either do it everything in meter and then convert. So for me, I have done by converting everything into centimeter unit. CGS unit and have done. Again, K10, K minus 10, it's already meter per second. If you want, you can convert that. I mean, either you can convert everything else into meter unit or you can convert that into centimeter. Then you have del value given as 10 micron, right? Again, you will have to convert into centimeter. EDC value is also given. So K10, K minus 10 is given. You will have to find out K1 and DC and K minus 1 DC. Could you please start doing? I'll give couple of minutes and then I'll also start doing. And if case you get the answer, you can let me know. So dA and dB are already in centimeters per square per second. So I am converting Ca bulk and Cb bulk into mole per centimeter cube. So you have 100 millimolar. So that is 10 to the power minus 6 mole per centimeter cube. I'll just simplify and write as 10 to the power minus 4. Cb bulk. Then K10 and K minus 10. 10 to the power minus 2 meter per second. That is, so into 10 to the power 2, if I am converting it into centimeter per second. So again, k minus 1, 0 will also be 1 centimeter per second. Okay, I'll write it in the same thing so that then you can substitute and find out. So dA, dB, CA bulk, CB bulk, K1 0, K minus 1 0. Then after that, B1, B minus 1 is given directly. It's again in the unit, you don't have to convert it. 19 volt inverse and negative 19 volt inverse. Then del is given at 10 micron. So micron to centimeter, you have to, so it will be 10 to the power minus 1, then it's converted to 10 to the power minus 3. If I multiply, it becomes micrometer, sorry, millimeter. And again, if I want to convert into centimeter, again one more 10 to the power minus 1. So totally it will be 10 into 10 to the power minus 4, 10 to the power minus 3 centimeter. EDC is 0.1 volt versus OCP. Substitute everything. Then the next thing that you need is K1 DC and K minus 1 DC. So how do you find out K1 DC and K minus 1 DC? It will be K1 DC equal to, please substitute that, K1 0, every other value is in, what to say. Please do it. I'll give you a few minutes just to check if anyone gets the answer, then we'll discuss. Anyone got? Or anyone is trying? Okay, now so K1 DC and K minus 1 DC something else we have to find out. I'll just do it. K1 DC equal to K10 exponential. Okay. So what is K10? We have already written something. Yeah, 1 centimeter per second. B1 value is 19. EDC is zero point 0.1, right? So you will get around 6.686. So as I told, please at least keep 3 decimal points, okay? Don't write it as 6.6 and continue, because you can try that. There will be a significant difference in the final answer value. So like because it's in millimolar, I mean finally you will be somewhere multiplying with some 10 to the power something. So then you will be again multiplying with 10 to the power and minus something. So those the decimal places keep changing. So if you don't have enough decimal places for that, you will have to put 0 and all. So that will bring a huge change in the number. This was the question I was saying. So you can, if you want, try and check. Okay, now K minus 1 DC. So B minus 1 is minus 19 into 0 0.1. So yeah, so you got K1 DC, K minus 1 DC. So you have the equation. So so D is 10 to the power minus 5. 10 to the power minus 4 is CAB. Del is 10 to the power minus 3. K minus 1 is 0.149. Like, are you able to get something of this form when you tried solving? I mean, did anyone get any answer? So K1 DC and K minus 1 DC we had already found. So that's how K1 DC I put 6.686. So I've substituted all the values. Can anyone tell what they've got? Can anyone tell me? Are you able to simplify it? Anyone got the final answer? So if I again simplify it, this is how I did. I'm showing the answer. Anyone got any answer? Is there any doubt in what I did? So I actually solved it before. So that's how I'm like, I'm looking at my notebook and writing it. I've already done that.
No, there is no doubt. You are going right thing.
Okay.
You understood.
Yeah. So when you solve this, so you'll get 4.499 into 10 to the power minus 6 moles per centimeter cube. So it's asked in millimolar, so I'm converting it back. So you have to multiply by 10 to the power 6. So this is the answer which I got. So it's basically simple. It involves so much calculation. That's the issue. So obviously it's a 3-hour examinations. You will have a mixture of theory based and numerical problems. So you can expect some questions like this. So the issue is going to be this lengthy calculation. So I would only suggest, because it's going to be the what to say your I mean PC calculator. It will take time, right, to type each thing and then find the answer. So do part by part, like this part first, then this part. Don't feed everything together to the scientific calculator, because if in anywhere you make a mistake or you get a doubt, then you'll have to retype everything. So best do part by part. So first do for this part, and then for this part, again for this part, then this one, and then write down each value. So in case you have any doubt, you can do and recheck it also. So that will make things easy. So finally, you will get 4.499 millimolar. Okay. So now, so no doubt, I guess. So the next question is to find out the CBS. So again, this is all related question. So what is the formula for CBS? Concentration of B at surface. So if you are from the previous question, if you are getting CS value wrong, then it's obvious that this question also you'll get wrong, because both are related, right? Like CAs you're getting from the previous question. So if in case you make a mistake in that value, your entire answer, this question also will go wrong. So there's a formula. Please substitute all the value and let me know what's the answer. So Ca bulk and Cb bulk is 100 millimolar. That is nothing but 10 to the power minus 4 mole per centimeter cube. I'm just converting it into mole per centimeter cube. Both Ca bulk and Cb bulk. So these values. This Cas we found as 4.499 millimolar or 4.499. Mole per centimeter cube. D and dB is already given in 10 to the power minus 5. Please substitute and let me know. Has anyone tried and got answer? So I'm just substituting. Did anyone get any answer? D and dB both 10 to the power minus 5. Say bulk is 10 to the power minus 4. Please, anyone do it and tell me what answer you're getting. Please do and let me know. Any answer? So 10 to the power 5. No one is telling any answer. This will go. So obviously 10 to the 2 into 10 to the power minus 4 minus 4.49 into 10 to the power minus 6. So if you do that, see, please try out, okay? Like, I know many were asking me to do the assignment questions also. So please give a try also. Like, just me doing will not make any use, right? I expect participation also. So only then there's a point in discussing that, right? Or else it's just to give the solutions for the questions asked in assignment, which is not actually the right way to do. Even some had asked me for derivation also, some asked me for the assignment question. So only if there is some kind of interaction and doubt clearance, I think it will make any use. So so there's a question which I said. So here it's 1.9551 into 10 to the power minus 4. So I have to convert it to millimolar. So if I had only 1.9 into 10 to the power minus 4, my answer will be 190.00. See, now if I do this, I am getting the answer as 195.51 millimolar. Okay. If I do not have, so this is the answer. And if you look the answer key, the answer should be between 195 and 196, I think. So instead, I'm just telling you, I solved it and I wrote 1.9 into 10 to the power minus 4 moles per centimeter cube. What will happen? My answer will be 190 millimolar, which is wrong. And even if I had, so at least I should have 2 decimal point, then I would have got 195 millimolar. So that's why I said this answer would be wrong. So just because all your steps are correct, just because your decimal places you have not taken enough number, your final answer can go wrong. So that's why I said when you're solving, do it part by part and make sure when you are simplifying, each term will have some 3 decimal place at least, so that you get the answer which is in the range. When you have multiple step involved and each step, if you reduce the number of decimal and you multiply finally by some 10 to the power some big number, your entire answer will change. So please keep this in mind. Okay? Any doubt? Now the next case, you have to find out the steady state current. So how do you find out the steady state current? It is so what is the steady current? So again, this is another question. If you don't get 7th and 6th question correct, this question will also go wrong. because this involves substitution of CAS and CBS. Got it? So please solve it. We have found out all the values. Did anyone get any answer? So the question is in nanoamps per centimeter square. So I'll be solving it in okay. I'll so yeah. So what all needs to be kept in mind? So you have F equal to 96,485 and unit is coulombs. That means is 96,485 ampere second. So I'm going to express this in milliamps, okay, and then I'll continue. Or you can keep it in 96,485 amperes, and then you'll have to convert into nanoamperes. Okay, that's also okay. So it's ampere second. Okay, I'll do like that. Okay, and then yeah, you know what is K1 DC, K minus 1 DC? We already did. That is it. In case you have to refer, K1 DC is 6.686 centimeter per second. This is 0.149 centimeter per second. This is actually a direct substitution, but under the constraint that if you have got a 6th and 7th question correctly, you can get 8th question correct. So you can expect such a connected question. So make sure you do not make a mistake in the first, those parts. Okay. Then CAS and CBS. So from 6th question, you get CAS value, that is 4.499 millimolar. So yeah, I'm converting it into 4.4 millimolar. So I'm multiplying it by 10 to the power minus 6 moles per centimeter cube. What is CBS? It's 195.51 millimolar. That is 1.9551 into 10 to the power minus 4. Please substitute the value and see if you're getting the answer. Are you able to follow what I'm saying? Just to confirm. Actually, no one is responding. That's why I just wanted to know. I'm writing over here after that. This one, okay? Continuation of that is written over here. So you simplify that multiplication, I mean subtraction thing. So you will get an answer. I'm just directly so this one is an ampere per centimeter square. So centimeter square. So I want to convert into nano. So I have to multiply it by 10 to the power minus 9. Okay. So if I do it directly, sorry, I'm reporting it in milliamps per centimeter square. Okay. That is this entire. So if you see, it is a big, that there is a mistake in this answer which is provided in the assignment. So it's corrected. So I will rather present this in milliamps per centimeter square instead of nanoamps per centimeter square. So for that, I'll be multiplying by this with 10 to the power 3. Ampere per centimeter square into 10 to the power 3 will give you 9 milliamps per centimeter square. 91.519 91.59 milliamps per centimeter square. So there's the answer you'll get for this question. They've asked it in nanoamps, then you can multiply again by another 10 to the power 6. So whatever you get, that will be in nanoamps per centimeter square to get in this unit. Yeah, so the next question is, what is the charge transfer resistance in this question? So who can tell the formulae? Again, this question is also linked. So in case you make mistake in your 6th and 7th question are the most crucial ones. In case you make mistake in 6th or 7th, that is in finding out CAS or CPS, your IF value will go wrong, your RCT will go wrong, and again, the RP value will also go wrong. Okay. So what is the charge transfer resistance formula? It's 1 by. Could you please try doing this? Anyone has any solution how to do? So again, so it's ohm centimeter square. So I'm directly going with the standard unit. So this will be 96,485 ampere second, right? B1 is how much? 19 volt inverse. B minus 1 is equal to negative 19 volt inverse. CAS is 4.499 into 10 to the power minus 6 mole per centimeter cube. Be careful with the units, that's the most important thing. What you can do is you just have to, so for this case I'll say it will be ampere second. You can just do this balance of the, what to say, the units and check. B1 is volt inverse, so it will be 1 by V K1 DC is centimeter per second. CAS is mole per centimeter cube, right? So in here also it will be 1 by V centimeter per second. So inside the bracket it is 1 by V centimeter per second mole per centimeter cube. So again, if I am just taking, so what is in the bracket is 1 by V centimeter and centimeter will get cut, mole per centimeter square second. So okay, sorry, it's coulomb per mole. Okay, it's not uh, coulomb alone, it's coulomb per mole. I made the similar mistake in the last slide also. Then please correct that. So it is coulomb per mole. So this mole and mole will also get cancelled. So what is ampere by volt? V equal to IR. So if I do, so this one will be 1 by ohm centimeter square. So what I have done is, so reciprocal of this is RT, right? So RT unit is ohm centimeter square. So basically when you get a question, just make sure if you have so much terms and you have any confusion, just try to balance the unit and also do. Okay. So CBS is 1.9551. Okay, now I'm substituting all the values. B1 is 90. K1 DC, okay, K1 DC and K minus 1 DC I didn't write. K1 DC is 6.686. CAS is 4.499. Minus 19 because beam negative, B1 for the opposite side is negative 19. K minus 1 DC is 0.149. CBS is 1.9551. And to the power minus 4. Please solve it and let me know what answer you're getting.
Please keep the same slide.
Okay. Okay, I'll change. I'll write the next part of it. Do it. What is the answer? Anyone getting? So this is the answer I'm getting. Are you getting anyone? Have you copied it? Are you getting the answer? So if you're getting it, then I'll be stopping today's class because now we've discussed 9 questions. So the next one is to find out the polarization resistance. Then 11th and 12th is a special case that I showed, like with EDC equal to 0. So I think I've already shown the equation. You can just try doing it. Then 13th and 14th is based on the semi-infinite, or I think, yeah, semi-infinite. So the finite one. So that again, so that one I'll show using MATLAB how I've done. MATLAB, in the sense, MATLAB, it's a single line. If you write, you'll get, or you can try it in Excel, because that 13th question, you have that finding the real and imaginary part. You have 1 plus k1 dc by root j omega ds. So by another term. So this by root j omega d, you have to again multiply, and you have another term also again with root j omega db. You have to multiply them with the conjugates, and then, so it is actually a lengthy process. So that 2 questions I'll show using MATLAB. Other than that, now I have to show you how you derive the polarization resistance. That I'll do, and the special case of that is with EDC. So that's left. Then before moving on to 13th and 14th question, I'll also do the other derivation. So that is what I planned for the next one, and if time permits, the next assignment questions also. Is that fine?
Yes.
Okay. So yeah, I think 10 weeks are over, 11th and 12th. After that, we are also planning, like they have agreed to keep another session, 2 hour session, just where I'll be summarizing what we have learned in this 12 weeks. So that's actually 3 months course. So what all we have learned, that will be another 2 hour session. So with that, we'll be winding up the course. So we'll have roughly 6 more hours of class. So this coming week and the next week. So after that, this course will be done. So if you have any doubt, you can post that in the discussion. In the NPTEL site, or you can ask me directly in the class. Okay, then we'll wind up today's class. Okay, you have any doubt? Okay, then thank you everyone. I'm closing.